set c equal to the function.
Yeah. Okay. So we have this function, which is a function we're using. Questions with a quadratic random generation of coefficients of a quadratic equation, trying to see what the probability is if you generate all the coefficients within some range, the probability of having a quadratic function with real solutions, with real zeros. Okay, so or the quadratic equation, corresponding equation, set equal to 0, having real solutions. Okay, so we start by just looking at the intersection here of this function with the plane z equals c. You get 2 square root of xy equals c. So that xy equals 2c squared. Okay, 4c squared. Right? 1/4.
Yeah,
Yeah,
be,
1/4 c squared.
yeah.
I'll blame it on the hurricane today. Okay.
It's messing with everybody.
I'm sorry?
I think it's messing with everybody.
No, I mean, we're just having some rain, you know. I've got to fly through Atlanta tomorrow.
Oh, wow.
And I looked at Atlanta, and boy, it was, you know, just right in the middle of everything, but I looked at the weather, and they're not expecting any winds over 20 miles an hour yesterday or today. A lot of rain today, but that's not going to hurt the airport, I don't think. My daughter is flying back from Boston, and she can only get as close as D.C. because Charlotte's shut down.
Huh.
They're going to have to fly to D.C. and rent a car. She's with a group of co-workers at a conference, and drive down from D.C. if they can get a car. So you'd think they could route them through Atlanta, because Atlanta, of course, Atlanta's probably going to be shut down for a few hours in the really heavy rain. I don't know. It's interesting. Anyhow, you can mathematically model that too. So go ahead and work that out and give me a probability my trip's going to be interrupted. Okay. Okay, so we have this, right? And of course, this is just a simple curve. Y equals c squared over 4x, a simple hyperbola. Okay? And it's going to have a graph that looks like this. Okay? So here's x and y. Of course, that's in the plane where z equals c. Okay? You go up to higher planes, and you get a bigger value of c, which just moves these things out from the origin. Okay? So for increasing c, we get this. Right now, we're only generating positive values of x and y. We already know that if x and y have opposite signs, the quadratic is going to be solvable, okay? Because x and y represent our a and c, do they? Yeah, whatever, yeah. Our a and c parameters in the ax squared plus bx plus c quadratic, okay?
I was wondering, why did we let b equal 0 again in this function?
Why do we let b?
Yeah.
B doesn't equal 0, B's your z. Don't worry about that connection.
Okay.
Let's just worry about the geometry of this situation. So now we have this plane, meaning that if we draw this function in the first octant, and we originally had all values between 2 and 6. Okay? So randomly generating values between 2 and 6. So that gives us a cube in the three-dimensional space, clearly. Lying above this rectangle, but starting 2 units high, and moving to 6 units high. So to depict this thing with some kind of clarity, hopefully, it starts here. Here's the base of the cube, and it goes up 6 units, so it goes up to here. Assuming this is 6, that's reasonable. Okay? Actually, that shouldn't even be there. But okay, so we come up to here, we come up to here, and it's going to look something like this. From here to here, we have to go in this direction, so from here to here, we've got to go in the same direction. So we fudge just a little bit to avoid some of my get choked up in these things. Swimming later, and I pop popcorn because it loads me with carbohydrates and seems to sit all right. Anyhow, so plus, you know, I've got the allergies and allergy season, so who knows why I'm coughing, but that was popcorn. Okay, now, so we get this cube, right? And it lies above this region, okay? And now we have the solution up here. Well, for C equal to 6, this would be 36 over 4x, right? Okay, so where is that up here? Does it intersect? Does it even intersect the top of this cube? Okay.